All right, so today we're going to discuss slope piping in AutoCAD Plant 3D. And basically, there we go. Wasn't responding to my mouth. Basically, the plan for today is we're going to do a brief summary of rise and run, just in case somebody doesn't know what we're talking about. I assume most people do when they're dealing with slope pipe, but we'll just go over that real briefly. Then we'll talk about drawing slope pipe from scratch. We'll cover both horizontal and vertical runs in the first little thing we draw. And then we're going to talk about existing equipment runs, because that's a little more difficult, lining up equipment and nozzles and things. So we'll do that, and that's a little more common also. From there, we'll talk about pipe slope editing on existing pipe. And we'll do a couple of things there, such as actually one that's not sloped at all. We'll slope it, show you some do's and don'ts with that, and then we'll look at changing the slope on an existing run. Then what I'm calling T time, because T's are very unique when you're doing slope piping. They are basically stop points. So we'll talk about adding or moving branches that have T's on them, and also vertical connections. In other words, you've got a sloped header that's feeding 2 or 3 different tanks. In our case, we'll use tanks, but a sloped header that you're going to be connecting up vertical connections to. And then last, we'll spend very briefly on your slope and offset tolerance. Technically, offset tolerance isn't part of slope piping, but if you do any offset type piping, it's good to know where you can set that tolerance, because it can't be done in the project setting. So that's just kind of a bonus just to point out. We're mainly going to be looking at the slope tolerance very briefly. So that's kind of our plan for today, and we'll start with the rise and run. And so basically, I'm just got it on a screenshot here just to explain. When you're drawing slope pipe, you're going to be dealing in Plant 3D with the rise and the run. So it's this piece of pipe that's on my screen. It has a 4.76 degree slope, but it has to be entered by a 1-inch rise, 12-inch run. If you want to look at it from your old trig days when you had to do mathematics, basically coming from page 174 of the 19th edition of the machinery handbook. I like to call it the machinery handbook for some reason, but it's the machinery handbook, page 174. That just shows you how I memorized this thing from so many years of using that stupid book. It has all your trig formulas for right triangles on that page. But basically, if you go back to high school, you've got if you know your A and your B, which we do know that's A is the rise, B is the run. To find angle A, it's A divided by B equals tangent A, which in our case of a 1-inch rise with a 12-inch run means 1 divided by 12 equals tangent of 0.083, which equals a 4-degree, 45-minute, 49-second angle, which equals 4.76 degrees in decimal degrees. You don't have to do all that calculation, though. All you have to know is A and B, your rise and your run. So that is what we're going to deal with here. So give me a second to switch screens here, and I'm going to put us with, I need to make sure, okay, so here is my Plant 3D project, which all I've got in here is some equipment that we're going to use and some existing pipe that has not got a slope that we'll use for the pipe slope editing. So first, we're going to look at it drawing horizontal and vertical runs from scratch. So because we're going to be working from scratch, I'm just going to hide these objects. And I am going to draw a 3D polyline only for visual purpose, not for any other purpose, but it's going to be basically the run we're going to do. So we'll go 50 feet in that direction, 50 feet in this direction. Then we're going to make a change for a vertical pipe and go 10 feet down and another 50-foot run. So that'll give us some piping something for you to follow. I could literally trace this, but I'm going to do it as if that doesn't exist. That's just for visual reference, so you can see it on your screen. So when you're drawing slope pipe, you're going to be doing that up here at the top. You have a slope section. I'm in a 3D modeling workspace. You have a slope section up here, which has your rise and your run and your slope. I'm going to turn it off first, and I'm going to set it here for 1/8 inch every 1 foot. And then I'm going to turn on the slope. This has to be turned on for it to actually route the pipe with a sloped angle. So I'm going to turn it on. It always goes down. Gravity slope is always down. So it's going to be doing a 0.6 angle at that. Looking at what we had before, 1 inch every 1 foot, 4.76. So it's doing the calculation for me. I do not have to actually calculate that angle. The other part of this is you cannot enter an angle. It just won't let you type into that area. It's always by rise and run. That's the reason I wanted to point that out at the beginning. You put that information in, it calculates the angle for you. So I'm going to pretend this line's not here and just route that. So I'm going to start with the horizontal routing, starting at 0, 0, 0. And it's just as I drew that 3D poly. I'm going to go 50 feet and make another 50 feet turn. So I've literally done a horizontal run right there. Not difficult at all. I want to refer to some YouTube videos. I did some YouTube, I always do YouTube research just to see what other people are putting out there. And what I found is everybody tells you when you're routing this to switch to pipe bends, use pipe bends and then convert those to elbows because there's so much difficulty with elbows and everything. But the product, actually, I didn't switch to pipe bends. I'm using elbows. It understands to rotate those elbows to cover for that. It also is using a 3-degree tolerance. That's the default tolerance out of box, so that it says if I'm 3 degrees or less in my slope, then it's not going to use cutback elbows. So there's no reason to worry about cutback elbows. Just let it run. The elbows will calculate correctly. I'm not sure why people, I think maybe back in many years ago it worked a little better with pipe bends, but you don't have to worry about that today. I haven't for years, so it's worked with elbows, no problem based on that tolerance. Here's the first issue though. I'm still got slope mode on. If I change, I'm using control right click to change. Notice it will not let me go vertical, only horizontal. It won't even let me go in the 45s or anything, only horizontal. When you're drawing slope pipe, you cannot make a vertical run. It just doesn't give you that ability. So when you're going to make those vertical runs, you need to turn the slope pipe off. Now I can make vertical runs. Now I have successfully changed elevations with slope pipe on, but it seems to be hit or miss. I don't know if it's where your mouse is or what, but sometimes it works, sometimes it's not. I always look for what works every single time. What works every single time, turn the pipe slope off and do your vertical run. Now I'm going to make one going down. I'm going to tell it to change the elevation. The elevation though, I could come over here and pick it, but depending on where it is on my screen, see if I come over here and pick elevation, I'm now running horizontal. So it's going to try to draw a horizontal run before it actually changes the elevation. So for that reason, my personal preference is don't pick it from the command line. That way I know I'm going down, type E for elevation. I'm going to go -10 feet. Make sure to always put your foot sign in there. And it came down to that 10-foot elevation, the same as I did with the polyline. I did it that way because I couldn't just go down 10 feet. I'm already sloped quite a bit down from where I went down 10 feet. I had to get down to the 10-foot elevation though to stay in line. So elevation negative 10 feet, not a 10-foot distance, because I don't want to calculate how far that is down. Use the actual elevation. Now I'm ready to draw the last horizontal run, turn the slope pipe back on, stretch the direction you want to go, 50 feet. So basically you can see from that line that I drew originally, I'm sloping 1/8 inch equals a foot, that whole 50-foot line. Over here, I'm right at that 10-foot. If I select this line, you can see I'm right at the 10-foot and then starting the rest of the slope down for the rest. So to get those vertical lines in there, I'm going to go ahead and delete this polyline because I don't need it for anything else. But to get that slope in there, the vertical line in there, you have to turn off the slope, change your elevation, and then turn the slope back on, because slope only works on horizontal runs, not vertical runs. Makes sense when you think about it, but the software is thinking in terms of horizontal runs only when you're doing slope pipe. So that kind of gives you an idea of how to draw it, but that doesn't help us when we're connecting equipment, because working with equipment is completely different because you're having to connect up to nozzles. So let's talk about that. I'm going to go ahead and end the object isolation, change to this view, and so you can see a little bit better, I'm going to go ahead and freeze what we just drew. We're going to come back to it later, and I'm going to turn off the concrete. What I want to do is connect up this nozzle on this heat exchanger to this nozzle on this tank. And I don't want to have to sit there and do IDs and calculations. So that's why it's a little bit different when you're drawing. I was just drawing distances before. Here I need to be very specific because, first of all, top of this steel, and I've removed all the rest of the steel, so for clarity, I know this steel wouldn't be hanging up in the air, supports and stuff, but I just wanted to get the concepts down and keep it clear. So top of this steel is 40 feet. Top of this flange here is around 20 feet. It's a little bit more than that, but it's around 20 feet. So I kind of have an idea here, but I have to have exact locations of where this stuff is. So the easiest way to do this is, again, add some construction lines that you can line up with. So this time I am going to add some construction lines that I can actually use. Now, like I said, it's about 20 feet. So I'm just going to say I want to get below that steel center of pipe around 36 feet. I'm going to roughly say that 16 feet. I do not have to be exact. The point is to get the plane, and that's what those represent as my plane. I mean, this is actually now, what, 36 feet and, oh, because it's a polyline, I don't get let me do an ID on it. It's around 36 feet and 2 3/8 of an inch. So it's not exactly the 36 foot, but it's close enough. If I'm within a foot or two, it'll work. If I get too low, if I had it at the top of that nozzle there, that's probably not going to work because I need to get to those perpendicular lines is what I'm going for. First thing I want to show you, and because I jumped ahead here, I'm going to isolate this and hide it temporarily. First thing I want to show you is talk about auto route of piping. I've got my slope on, and this is going to be steam condensate, so it may not be in real life, but you get the point. If I tried to auto route from here to here, it'll give me options. It's giving me 9, but I can guarantee you none of it. I'm going to have to move this down a little bit, this part of the screen for the webinar. Okay, out of the way of that. But you can see here, that's not sloped at all. Nowhere at all. And I could go through every single one of these. None of them is going to slope the pipe. So rule number one of things to remember, auto route does not do slope pipe. It's impossible for it. I mean, well, it's not impossible. It's just it doesn't do it out of the box. So the auto route does not help me. If you ever watched one of my videos of, let me undo to get back to that angle I was at. There we go. If you ever watched any of my videos that I've done of connecting up pipe, I use auto route a lot to connect up and line up to my nozzles so that everything's in line and to work. But in this particular case, working with slope pipe, it's not something I could use. Therefore, I needed the construction line because I need to make sure I'm lined up with the tank when I come out here, and I need to make sure I'm lined up with the nozzle when I come out here. So let's route this for slope pipe. I'm going to start the routing of the pipe, select the nozzle, and I can't go down because that's going to be a vertical run. So turn off the slope pipe, and I'm going to pull my nozzle down, and I'm going to go to an elevation of 36 feet. So that gets my vertical run in. Now I'm going to be going to a horizontal. Now I have found when I'm trying to get to the perpendicular on a line, it is best to have my compass in a top view. Don't have to, it will work in other views, but again, sometimes I get a different result. So I'm always looking for every time what will work. Top view compass works every time without error. So I'm going to turn that on, turn my slope on. Now, when I'm dealing with the perpendicular on a line, especially when it's not exactly at the same elevation, I have found it's always best to be in a 2D view. Doesn't matter whether it's the view I need or not, I just need that line in a 2D view. I'll do a shift right click and go to the perpendicular of that line. The 2D view helps it to not care about the elevation being the same. Now I'm going to go to a view of this direction. I don't care that it's upside down, it's still sloping right. So I'm going to go shift right click to the perpendicular of that line. And then I'll go back to my 3D view so you can see that it's been following everything correctly and sloping. Now, this time I don't need to turn off the slope toggle because I'm going to connect up to the node here. Auto route will take over and it will go ahead and give me this message. Now let me explain this message to you. The top one is telling me it may result in cutback elbows or disconnected pipe. I don't care about that. Since I am within that 3-degree tolerance, then I don't want it to use cutback elbows. I want it to connect with the tolerance. So as long as I'm within the 3-degree tolerance, that's the default setting, we can change that. That's what we'll do last, is show you where you can set that. But the out-of-the-box 3-degree tolerance, then I can connect with tolerance. I don't need to worry about cutback elbows. So I'm going to pick that one, connect with tolerance. It connects up, and I've got slope pipe going to all the equipment in those horizontal runs. So that's the way you can connect up your equipment using slope pipe. Again, concentrate on vertical runs being not using slope. Horizontal runs is all we're using slope on, but I use those construction lines, just 2 of them, to be able to line up with the tank and then line up with the nozzle. That way I have no errors. So a little bit of construction line is required when I'm doing this. So the next part we're going to talk about is pipe slope editing of existing pipe that's not sloped. We'll start there. So we're going to use this drain pipe over here. Let me turn everything back on because that concrete will come in handy. Let's turn off the original slope pipe so it doesn't make it look weird. And I'm going to turn off this support so that we can see it a little better. Now, the first thing I'm going to do is a predecessor to T-time. We're going to do it a little bit and show you what happens if you include a T when you're trying to set a slope. So I'm going to select this piece of pipe. One piece of pipe is all you need for pipe slope editing. If you select two, it won't let you do it. Just one piece of pipe in the run, everything else will be set from there. Right click, and there's pipe slope editing. We'll select it, and you get this dialog box. This dialog box works from top to bottom. If I set the bottom stuff and then start setting stuff up top, it will change it back to its default setting, or sometimes to something I don't even want. So you need to set this stuff, just go down top to bottom. I'm going to start with the start point. I'm going to cock this a little bit. And like I said, this one's not going to work, but I want to show you why we can't use a T. And I'm going to take the center point of that T right there as my start point. So I'm going to shift right click and pick the node and get the node of the center of that T right where the branch is. Then I'm going to come over here for the end point. And right now you can see the end point is the end of this piece of pipe, and I want it to be the face of the flange. Otherwise, it's just going to break the pipe from the flange. So we'll make it the face of the flange. We're going to maintain the elevation on the end over there. It's sloping towards the flange. So I want to calculate by end elevation. Start elevation would be a backwards calculation. So end elevation, and we're going to go ahead and make it 1/8 inch for a 12-inch run. Now, in this particular dialog box, I could actually add the slope degrees. I could come in here and say, I want a 1 degree slope. When you click out of it, it recalculates the rise. So you can actually do degrees from here. You couldn't do it when you're drawing. Personally, I like to always do rise and run. So I always let it calculate. But notice it will not change that slope degree until I click out of the box. So anytime you make a change, you have to click out of it. So even like if I wanted it to be 18 inches, if I did it right now, hit OK, it's going to do a 0.6 degree slope. It won't change that calculation until I click out of it. So let me go back up here and do the 12 inches. It's going to be a 0.6. We'll hit OK. All right, so here it's telling me the slope angles, and this is really a deceitful message because it's telling me it exceeds the tolerance that's in the software. It's really not. That's because I've got a T in there. It doesn't know how to handle that. So it's going to cause a pipe to disconnect because the T cannot have a slope angle. As soon as I hit yes here, it tells me now the parts don't fit. Hit close. It tried to slope the pipe, but if I come up here to the T, you can see I now have leaks, 3 of them, because it broke that T from the 2 reducers and from the pipe. Now I could easily, since the T didn't actually move, connect the reducers back up to the T. That solves that problem. But it will not let me connect the pipe back to the T because they don't connect anymore. It's broken. That's why I can't include a T. T's are special parts of the software that are breakpoints. So T's cannot be included in any slope editing. Just like you can include, I'm not drawing T because that would be after the slope. Also, which we'll deal with that in a minute, also how to handle branches on a slope pipe. So I'm going to undo this back just to get it back before the slope. And this is the way you would slope this particular situation. I did not mean to turn those back on. I undid too far. Pick the pipe slope editing. Endpoint's going to be the face of the flange. It's going to calculate by end elevation, 0.125. By the way, it doesn't remember these settings. I wished it did. You have to type them in every single time. And you always have to remember to click out, hit OK. That one worked as it's supposed to. So it slopes from the T to the face of the flange. You can't include the T. So that's the second rule, or the third rule actually. The second one was that dialog box I explained of working with the tolerance. The third one is you can't slope a T. What about an existing line? Let's turn everything back on. An existing line that already has a slope. Well, we're going to use this line over here again that we did originally. And I'll isolate to where that's all we see. And we'll get back to the southwest isometric, just so it looks like what we did when we drew it. So sloping a pipe this already has an 1/8 inch slope. I meant for it to have a 1/4 inch every 12 inches slope. So I want to modify it for 1/4 inch. Again, select one piece of pipe, right click, pipe slope editing. Just to show you I'm not crazy, I select 2 pieces of pipe, right click, no pipe slope editing. 1 piece of pipe in the run is all you can select. So we'll go pipe slope editing. I'm just going to make this one fail right off the bat and pick the endpoint down here at this piece of pipe. I've got a vertical pipe in there. Vertical pipe can't be sloped. Therefore, I can't slope based on what I could selected because of that vertical pipe. So rule number 4, you cannot slope vertical pipe, even in pipe slope editing. So let's fix this and do it correctly. We have to do it in 2 sections to not include the vertical. We'll pick the endpoint here of this piece of pipe. Notice I'm not zooming in and picking the end of the pipe. I'm picking up here. That's another thing to keep in mind. I've seen people like on that T situation, they pick the weld right where the pipe is ended. When you do that, you may accidentally select the T. The software will select it and then it's going to break. In this case, if I would have picked that point here, zoomed in, it would have picked that elbow possibly. 9 times out of 10, it will. And the elbow can't be included in this because it's part of the vertical run. So it's the end of the pipe right there. And then end elevation, and I'm going to change it to 1/4 inch for a 12-inch run. You can see the start elevation is 0 because that's the start point down here. I made the end point down here. Now, when I do this, I'm going to get the same message that we got with the T, but this time it's okay because it's basically going to break it from the elbow. Hit OK, same message we got with the T. I'm going to say yes, and it broke it from the elbow, but that's an easy fix. All I have to do is delete this piece of pipe, move this elbow, and then connect up the vertical again. Easily fixed, but I had to break it to get the slope to work and then just fix that vertical area. Just to make this one match, I'm going to finish this one out. Again, endpoint, it's going to be down here. End elevation, we'll give it the same slope of a 1/4 inch for 12. So I had to do it in 2 sections because of that vertical line. So that's how the pipe slope editing works. So what about T's? How do we handle branches off of the pipe? So I'm going to kind of switch angles here. It's easy just to add a T. This pipe here is sloped. So if I just want to add a T and a branch off of it in the middle, just like drawing pipe, just hit the plus, come off. We'll say 50 feet this direction, 50 feet this direction. That's easy, and it's yeah, I had slope on. Now I'm going to redo that only because I meant to change my slope to 1/4 inch equals a foot, and I forgot to. So that it It's quarter inch equals a quarter inch per foot. And I found lots of times when you change slope, it's best to click it, toggle it, to make sure the software got that change, because sometimes I've even had that happen to where I've changed it, but it didn't actually take the change, and toggling it always makes it take. So we'll do that again. Midpoint 50 feet by 50 feet. And if we look at it, you can tell it's sloped all the way. So this is no big deal just to add a T in the middle. The problem comes if you need that T to be in a specific spot. We're going to leave that one there so we can talk about moving a branch in a minute, but let's say you need a T in a very specific spot. So from this vertical line running here, I want a T that's exactly 10 feet from that vertical line. It's no different than if I was adding a valve or a T on a line that's not sloped, but I've got to add it in there for it to work. So what I'm going to do is add the T from the tool palette, just like you would normally. But there's a couple of issues to get that 10 foot. Notice it's going to the end of the pipe because I've got nodes set for my O-snaps. Now I have to have an O-snap to get it to go on the pipe. So just like with a valve, my suggestion is always use nearest. That way you can get it in the pipe. And you notice it's given me, because I've got dynamic input, those dimensions. Just like with a valve, they're not very valuable. I mean, I could eyeball it to get it to 10 feet, but there's no guarantee I'm exact on that. So I would normally think I could come down here and tell it go 10 feet that way, but you notice how it snapped to the end because that's the nearest point it's finding at that point. I can't get it 10 foot over, it's going to be there. So again, when you're doing this, just like with a valve, it's best just to get it placed anywhere and get the direction set. Then come back to this and hit the move part. In the middle, you get those dimensions again. This time they'll work as long as O-snap is turned off. If I try to leave O-snap on, it's going right back to the end. So turn off your O-snap to where there's not any O-snap. Select that move part. You get those dimensions and they'll work this time. You can come over here and say 10 foot. Those dimensions seem to only work if O-snap is off. The problem is to get it on the pipe, you have to use an O-snap. So it's place it, then get it set immediately afterwards. Now, I want to show you one dimension here because it's going to come into play. Notice it's from that middle one, it's 15 foot, 0 1/8 of an inch. We'll come back to that in a minute. I'm referring to, whoops, see, I moved it off. I'm referring to that right there, that dimension to get 10 foot from the end because that one's in the middle. All right, here, once I've placed it, I can then start drawing slope pipe. I've never turned off the slope pipe at this point. 50 foot, 50 foot, everything's sloped. I just had to get the T in there first at the position I wanted it. So that's how to get the T's in there and then draw your slope pipe from the T. Now, what about a line that's existing already? Well, there's 3 ways. Let's say I wanted this one line here to be 10 feet right there. I want that to be a 10 foot dimension. There's 3 ways I can do it. The fastest method would be, I know that was 15 1/8. I pointed that out a minute ago, is just to take this pipe and move it 15 feet and 1/8. And there you go. It moved it at 15 foot in the horizontal plane, but it actually kept it on the slope and fixed it on my elbows. So that's the fastest method, but it's also the least accurate. The reason I say it's the least accurate, that 15 1/8, you think about AutoCAD rounding, it's rounding to the nearest 1/8 or 16th or something like that. I think this one's rounding to the nearest 1/8 in this particular drawing because that's what the units are set for. If that's the case, 15 1/16 would round to an eighth. 15 3/16 could round up or down, depending on where it is, to an eighth. So I could be as much as a 16th of an inch off. So I don't personally like that method because I'm trusting the rounding to be exact. And I don't know that it is. And I don't want to have to go check that and do distances with the units higher or anything like that. So that's the fastest method, but the least accurate. Give you two more methods that I could use that would be accurate. One is draw a construction line. I'm going to draw it off. Let me turn this back on, make sure it's on node. And I'm going to draw a construction line from that node on that elbow, move it 10 feet, and then go to my top view here and move this to the perpendicular. That's exact. I know that one is correct. So that's the second method. That one, using the construction line, will also modify this. So the third method that you could use, I'm just going to undo to get it back, is similar to what we did down here. But unfortunately, you don't get the dimensions on the move part when you have a branch, when you already have pipe connected to it. So the third method would mean deleting this pipe and then setting the nozzle, the T. O snaps off, 10 feet, and then redraw the pipe. I had O snaps off, but I didn't keep my O snaps off. All right, O snaps off. See what happens when you don't have your O snaps off. Those dimensions do not work. So now I've got it 10 feet over, and it would be simply 50 feet, 50 feet. So the first method is the fastest, least accurate. The second method is the most accurate and doesn't require drawing the pipe again, and it doesn't require setting a construction line. The third method, no construction line, but I have to redraw the pipe. Which one's faster? I don't know. That's up for you to decide. But it gives you three methods how to control those branches and still maintain slope pipe. The next part that we want to cover that was in our outline is vertical connections. In other words, we've got, let's go over here to this tanks right here. So let's say we want to have a header feeding these three tanks. We already got one in here. We want to have a header that feeds the next three that is sloped. I also want to use as little pipe as possible. So I want to be able to have a flange with an elbow and then come back this direction and then connect up to that vertical connection there. And I've saw on YouTube some pretty convoluted ways of how to do this. I personally think this is the simplest method, but this one actually is fairly complex because we've got two issues. The vertical pipe here, T, are connecting up, but we also are connecting up to a vertical pipe that's existing. So we got two different separate issues in this particular situation. So let's show you how to do this. We're going to start by just drawing from this tank backwards. That means our slope is going to be going opposite. This is the slope. We want the slope going this direction. So since we're drawing backwards, we need a negative slope. Okay, so that's the first thing. So I'm going to change here, and to make it very drastic so you can see it, I'm going to do a 1/2 inch slope on this particular header. 1/2 inch for 12. Again, I toggle it. That will allow, I'm doing a negative 1/2 inch, so it'll be a uphill slope instead of a downhill slope. From here, let's go ahead and change back to our steam condensate. I'm going to route the pipe, go from the node. I need to turn this back on. It is set to node already, so I got my O snaps back on, connect to the node, and I'm just going to go backwards. I'm going to overshoot here. I can't draw to the perpendicular of this tank because I'm running at an angle. So the perpendicular on that line is not, it's going to be connected at an angle. So I'm going to just overshoot it because all I'm after here is this pipe to be able to draw a construction line, because the only way I'm going to do this is with construction lines. I'm going to need 3 total. I'm going to draw the first one for this pipe here. That way it's the correct slope and location for the center line of the pipe. I don't need the pipe. I'm going to erase it because I got to get the T in there first. The next thing is I need to be able to connect up to that nozzle. So I'm going to need 2 T's, one here and one here. This one's a T connecting on a slope on the branch. This one's a slope on the main line, the header. So the next thing I need is a T in here. I could put it off the vertical. I could put it off the tool palette, or I could just simply come in here and draw this. But notice I'm sloping up, so I need to correct my slope up here back to a 1/2 inch downward. And I'm toggling it so that it will take. I don't need this piece of pipe. I'm simply interested in the T. But I needed to get one in there. All right, so here's where I need the T to go down here. Now here's the part that confuses people sometimes. You know, what I saw happen in a lot of YouTube videos where people couldn't get them to work, and some of them, they were asking questions. They're trying to line up. Let me zoom in on the T. They're trying to line this point with the slope. But think about it. If the slope is going, I'm going to draw it real drastically. The slope is going here. The outlet where I'm actually connecting the pipe is not going to be lined up with the slope. What's important with the T here in this situation is the outlet of this T. That's what I've got to line up with the slope of the pipe. So I'm going to draw my construction line from the outlet of the T down. This will solve the issue that most people have with this situation. Now in this case, I'm going to go back. Again, I found it works best when I'm going to be dealing with these things to be in a 2D view. This just works every time when I do that. So I'm going to take this and move it down. But the thing is, I can't pull, if I pull this off the pipe even a little bit, it comes off, I can't get it back on in the right place. So I need, if I'm here trying to move it and then I right click, shift right click and go pick something, if my cursor, when I did the shift right click, is not in the right place, I'll pull it off the T. So I've found for it to work every time without flaw, I need to set my O snap when I'm dealing with the T's to what I'm actually going to be doing. In this case, I'm going to be connecting to the apparent intersection. That intersection is a hair off. I guarantee it, I couldn't draw a line from the intersection. So apparent intersection solves the issue. And I'm going to move this T down straight, keeping my cursor, keeping it on the pipe to that apparent intersection, and that gets it lined up. The outlet, you can see here, if I zoom in, it's not on that right there. It's crossing through there. So that's why I use the outlet. Once I've got that in there though, it's ready to connect up, and I could connect up. Got to change, I'll just shift right click for the node. And there you go. I got my slope pipe on the header correct. Now I need the header, the T on the here to be correct. So I'm going to go ahead and come here. Again, this needs to be on nearest to put a T. I could also do it the same way. I'm just doing it from here this time. So I'll connect it there, make sure it's going down. And then at this point, it's just moving it in there to the perpendicular, but the same thing applies. I need it the outlet to the perpendicular, and I don't want to pull it off, so I'm going to go ahead and change it to the perpendicular and move the outlet to the perpendicular, keeping it on the pipe. And now I'm lined up. But there is one more issue here when you're dealing with nozzles on a tank. We'll get it more like this. When you're dealing with the slope angle tolerance, the slope tolerance, I'm below the 3 degrees, so I'm good there. That's for piping, not nozzles. Nozzles do not recognize the slope tolerance. So because of that, and this coming in at an angle of that 2.39 degrees, it will not let me connect. Let me go ahead and change back to node here, because I'll be doing a couple of those. It will not let me connect this up to that nozzle. Even if I try to connect with tolerance, can't find any paths. It's messed it up. That's because nozzles do not understand the slope tolerance. They're not part of that calculation. So therefore, I cannot go from T to nozzle. That's rule number 5. Can't connect T to nozzle on a slope pipe. So I have to route backwards, which is no big deal. Just go from the nozzle to the T. Now it's the flange that connected up, so that it can handle. So when you're connecting a T on a sloped piece of pipe, you have to go from nozzle to T, not T to nozzle. Now we're going to do this once more with filling, just to let you see it in another situation, because this one was pretty complex because of that T right there. Down at the bottom here, I'm going to be doing the same thing. I left my flanges because lots of times when you draw, you may have drawn the pipe and you're erasing it. Don't erase the flanges, then you don't have to worry about the slope tolerance connecting with the nozzle, because the slope tolerance will be considered for a flange. So in this case, I want to leave the slope 1/2 inch equals a foot. We are going to make this drain pipe. I'm going to route from the bottom here 30 feet. And you can tell by looking at it, it's sloping. Got that header in there, so now it's just connecting up these flanges or these nozzles where the T's are going to go. So again, I'm going to draw a line from the node straight down. I've got my ortho on. That's why I'm able to draw these lines straight down. So there's where my T's need to connect. I just need the T's in there. So I'm going to go ahead and put a T. I'm just going to get it in here. Again, I'm going to change this to nearest and get it going up in both situations to a 2D view. Moving the outlet. Let's go ahead and get this set to perpendicular first. So I'm going to move the outlet to the perpendicular. Move the outlet to the perpendicular. They're lined up now. I don't need my construction lines anymore. And in this situation, let's switch back to node. I found you don't want to try to connect stuff up with perpendicular when you're connecting the pipe. I can go from T to flange, or I could go from flange to T. Either way, same results. But you can see here, I've got that header connected up. So connecting up those headers, when they're sloped, you just got to get the T's in position based on the outlet, not the T on the main branch. Once they're lined up, they're pretty simple to connect at that point. So that basically shows you several different situations for connecting up slope pipe, and covers pretty much everything except for the slope tolerance. Slope tolerance is not set in the project setup. It is set in a specific file. Let me go over here under the Treadstone project. This is my project. It's set uniquely per project, and it's this default connectors config XML. That's where slope tolerance is controlled. Open it up in an XML editor or in Notepad. Under joints here, I know the one I'm using is this one here, which is butt weld, because everything I was doing was butt weld. And right there's my slope tolerance for the project. Now this needs to be set with the project closed. If I set it right now, it won't have any effect on this project. I have to close Plant 3D or change to another project and change back again. But I could come in here and set that to a 5-degree slope, and now I would have a 5-degree slope tolerance. So now the one that was in the first screenshot I was showing you, a 4.76 degrees, would actually work without any errors and without any cutback elbows. But I want you to be careful with this. You don't want to set your slope tolerance to something you cannot do in real life. If you set this to a 10 degree to where you're not having cutback elbows, in real life, they can't do an elbow 10 degrees. So you're going to cause yourself issues without having the cutback elbows. In that situation, I would need the cutback elbows. I personally like 3-degree slope tolerance because that I can realistic do. I'm not sure. It'd probably be difficult to do a 5-degree slope tolerance without cutback elbows. But I know I can do 3 degrees. That's the default out of the box. So I really, personally, I'd never change this. The other thing you have to remember here, slope tolerance is per joint. So you can see this is just for the butt welds. If I look at this first one, that's for pipe bends. It has its own slope tolerance. Go down here, I'm just going to pick one. Socket weld, slope tolerance is 0.1. Makes sense. That you can't really change a socket weld elbow very much. So that's about all you've got. Here's threaded, 0.1. So slope tolerance is per joint in this file. You can change it one place, that only changes it for that particular joint. 3 degrees makes sense for butt weld. 0.1 makes sense for threaded when you think about it. So the slope tolerance is set in this file, and your bonus is offset tolerance is also set in the same file. So if you ever need to change the offsets, there's your bonus right there. It's the same file, but it's all per joint. So that kind of shows you everything we've talked about. Let me close this file, and I'm not going to save it. And let's go see if we have any questions. Questions right here. Not one single question today. I'll give it, just in case somebody has one, I'll give you just a few seconds here to ask it. If not, we will be turning it over to Ashley here shortly. So anybody got any questions? Well, I guess that means we have been pretty thorough in our description here. So I'm going to go ahead and turn this back over to you, Ashley.
Okay, well, thanks, Rick, for the presentation. Thank you, everyone, for attending today. If you do think of questions later on, you can simply reply to that confirmation or reminder email you received from GoToWebinar, and we can get those to Rick or your sales rep to get your questions answered. Also, just a reminder that a short survey will pop up as we close down. We appreciate if you'll fill that out for us. It's just 4 questions. Also, everyone will receive an email tomorrow, which will contain a link for the recording of today's presentation. And I don't see anything else in the question panel, so we'll just go ahead and close today, but have a great day, everyone, and thanks a lot.